All right, so simplifying radicals. If these are not perfect squares, how do we break them down?
4 and 5.
Okay, so we could start there. We could do 4 and 5 on that 20, right? So this becomes 4 and 5. Can 4 get broken down?
Yes.
2 and 2. Then the rule is what? For every pair of numbers, that number goes to the outside of the square root, and anything that doesn't have a pair stays underneath, right? So because there's 2 2's, a 2 goes to the outside of the square root, and a 5 that doesn't have a match stays underneath. So you're writing this down with me. Yeah.
And why do you do all that and you can't just do like 4?
So sometimes it's easy to just find those, and sometimes it's not as easy to find those. If you saw the 4 and you wanted to square root the 4, why are you not cooperating? You totally could just square root the 4. So you can do it that way. It's just the bigger the number, the harder that is. Okay, so now go to 80. How do we break down 80?
10 and 8.
Okay, all of those are right. So start that wherever you just started. I'm going to do 2 and 40. Because I know 2 is prime and that's as far as I want to go on that one. Then I'm going to go to 40. 2 and 20. And then 2 and 10. And then 2 and 5. So no matter how you started, if you did 8 and 10, 8 would have gotten broken down into 3 2's, 10, 2, and 5. You should still have exactly what you see here, which is 1, 2, 3, 4 2's and 1 5. So each pair of 2's means one of those 2's is going to the outside of the square root, right? That's 1. That's 2. The 5 doesn't have a match, so the 5 is staying underneath. Multiply the 2 times 2, and I get 4 root 5.
How would if you do 10 and 8 and just break 8 down to 4?
Yeah. And then you can say 4 becomes 2, and then there's another pair of 2's, and then there's the 5. So answer should still be the same no matter how you break it down. Still good? Yep, David?
Wait, so like, how come you just got 2 2's instead of the 4's over there?
How? Up here, you mean?
Like how there's 2 times 2 times 2 times 2 times
Yes.
2 times 5?
Each pair, 1 goes to the outside.
Oh, okay.
Yep. Because you're really saying that the square root of 2 times 2, which would be the square root of 4, is 2. So every pair, 1 of those numbers goes to the outside. All right, let's do 240. So Isabel said she did 10 and 8. So you can also do 10 and 8, but then you got to keep breaking it down. So 240. How do we break that? Okay, 120 and 2. 10 and 24, fine, but then the 10 breaks down and the 24 breaks down, right? 2 and 120, now the 120 becomes 2 and 60, 2 and 30, 3 and 10, or 5 and 6 is fine, 2 and 15 is fine. Either way, you're going to keep going. Sure. And then 15 becomes 3 and 5, right?
Yeah.
Yeah. Yeah. From the beginning? Yes. Oh, after this one? Yeah, I'll do it. Okay, so now I'm going to write out all the numbers that are there. All the dead ends. All the ones that don't have another number coming off of it. That's a 2, a 2, a 2, a 3, a 2, a 5. So I wrote all the ones that didn't get broken down any further. All the dead ends, right? Now I've got 2 2's. One's going to the outside. Another pair of 2's. Second 2's going to the outside. A 3 that doesn't have a match is going to stay underneath the square root. And this time a 5 that doesn't have a match. It's going to stay underneath the square root. Good. Multiply what's on the outside, you get 4. Multiply what's on the inside, you get 15. Okay, so Lisa, you did. Huh? Oh, okay, perfect. All right, you do D on the right-hand side. Break it down. All right, now we're solving. Which is what? If we have two ratios that equal to each other, what's it called to solve it? Cross multiply. We'll go back over them at the end. Yeah. All right, so I'm going to cross multiply. This times this and this times this. So 3 times x equals 2 times 5. 3x equals 10. And then I would divide both sides by 3. And x equals 10 over 3.
Can you get a decimal?
Sure, except this time that decimal is not going to stop. So you don't want it because it's not going to terminate. What you want to do is convert that. You can either literally keep it the way that it is as long as it's a simplified fraction. Easiest answer is 10 over 3. If you want to convert it to a mixed number, I'll go there. Then it becomes 3 1/3. Okay? If you divide, it never stops. It goes 0.333333333333333.
Does that focus on the test? Did it as a decimal?
Okay.
Can we just?
Decimal, the one on the test terminated. So it's fine.
Yeah.
Yeah.
What's the decimal?
This would be 0.3 repeated. So
Can you just put 0.3 and then divide it?
yeah, but if it asks for an exact answer, you would want this or this. Those are better answers than something that repeats.
So I get it.
I don't know if I get it. As long as you put the line over it, I wouldn't have marked it wrong. Yeah. Okay, then we've got it where we have to cross multiply. There's an expression this time. So these two again get multiplied together. These two get multiplied together. 6 times x plus 2 equals 4 times 10. What do I do with that 6? Distribute it to both. 6x plus 12 equals 40. Good.
28.
And then divide that.
Sure can. So I could simplify it 2 ways. One, first of all, I said you can leave it improper as long as it's simplified. So you can't leave it as 28 over 6 because those numbers can be reduced, right? What goes into both 28 and 6? 2, 14, and 3, right? That is reduced. Or I do 14 divided by 3, and I get 4. That's 12 and 2/3. So either one of those answers would have been okay. If, again, you're dividing this time, that also doesn't terminate. It would be 0.6 repeated. So a better answer here is 14 over 3 or 4 2/3. All right, you do C and D. All right, how do we find geometric mean?
That's the one that got last.
How do you find geometric mean?
You have to
Square root that number times the number, right? Number times number. So they square root the product of the two numbers. So if it said 12 and 45, do you want to multiply out 12 and 45 and then have to break it back down again? Heck no, right? Don't go through the extra work. Good. So I would do 12 so she said 4, 3, right? And then 4 breaks down into 2 and 2. You could have done 2 and 6 and 2 and 3, same 3 ending numbers. 45, what'd you say, Alyssa? 5 and 9? And 9 becomes 3 and 3. So if I write out all the dead ends, all the ones that stop, it's 2, 2, 3, 5, 3, 3. This is called a product of primes because those are all prime numbers. Then do the same thing we did at the top because technically it's the square root of all those numbers, right? So this pair of 2's brings 1 to the outside. Pair of 3's brings a 3 to the outside. 5 doesn't have a match, that's going to stay underneath. And a 3 doesn't have a match, that's going to stay underneath. So I get 6. They're having so much more fun than you. I'm really sorry. 6 root 15. Questions? This is where it went real south.
Oh yeah.
I know I got X and Y.
Not for everyone, but wow. When it went south, that was 6 questions. Yeah.
So look how it's working. I started drawing.
Yeah, that's lovely. All right. Shh, there's no mercy points for drawing. There were 2 proportions from this section, both involving a right triangle. So if I have a right triangle, the big triangle had to be a right triangle, and then I have an altitude drawn to that right triangle, which looks something like this, okay? There's all these different parts to this triangle. There is a hypotenuse of the big triangle. Let's call this H. Add this on because it's not there. There's an altitude of the big triangle, which is the one inside. Let's call this A. There are two legs, so we're going to call this one leg 1 and this one leg 2, and it doesn't matter which one's which, but there are two legs. They are the non-hypotenuse. And then there are two segments of the hypotenuse. Let's call this segment 1 and let's call this segment 2. Again, it doesn't matter which one's 1 and which one's 2. So part of the challenge I think some of you had was just even identifying what's what in that triangle, right? Because there's technically 3 hypotenuses. So if I ask for the hypotenuse, I mean the hypotenuse of the big triangle, and that gets tricky. If I ask for a leg, I'm talking for a leg of the big triangle, and segments are based on the hypotenuse, which is now divided because of the altitude. Does that make sense? Yes?
Yeah, we get half points if we did some of it right.
Yes. Yeah, I told you yesterday or the day before too, like even if you gave me the setup of the equation and all the math went south from there, I would give you points, but some people didn't even go there. Yeah.
Yeah, like I like it as a jump.
That's what I actually did.
All right, so the altitude proportion was what? Do you remember?
Leg. I know the bottom one is leg on the first one.
That's on the leg one though, but what about the segment with the one that has the altitude?
Altitude over segment 1.
Segment 1
Over altitude.
over altitude.
Altitude almost.
Good, equals altitude over segment 2. So if I do the one that's there, right, what would be segment 1? We just labeled it as what?
12.
Oh, no, the little drawing we just made, S1, right? We called it S1, right? And then the altitude was the A equals the altitude. That's the one that's going to repeat. So there's always one that repeats over the segment 2, which we called S2. Okay, then there's the leg proportion. So Alyssa, you said you want to do this one?
Oh, isn't it like hypotenuse
Yep,
over leg?
yep. And remember, there's always one that repeats. So the leg is the one that repeats, right? Equals leg over
Segment 1.
segment
Adjacent.
Oh,
of the hypotenuse.
I'm gonna say it's so how.
Yep. Adjacent to the leg. Are you being sweet to each other? That's so cute.
Okay, so which one would that be?
All right, so there's 2 here, right? Because there's 2 legs.
Yeah.
So there's 2 different ratios you could set up. Let's say I want to find leg 1. Hypotenuse is the hypotenuse no matter what. So that's H. Now I want that to go over leg 1. Equals the leg 1 that repeats. What segment of my hypotenuse is adjacent or next to leg 1?
Segment 1.
Segment 1.
Yeah, I didn't get any of this.
I was like, oh, I'm pretty sure I got all of those wrong.
Then would go the next one, right? Hypotenuse again over leg. Now let's say we're doing leg 2. Would equal leg 2. Which segment is next to that one?
That does make sense.
This makes a bit more sense. Because before I didn't know what a hypotenuse is.
All right, so the first thing I want to know is if that's X, what kind of segment is that?
It's altitude.
That's the altitude. So what of the 2 proportions am I going to use?
The first one.
Segment 1 over altitude equals altitude over segment 2. What is segment 1?
Is that the smaller triangle?
Doesn't matter.
What do you use 2? 'Cause it's
It could be 2, it could be 12. It doesn't matter, right? Segment 1, segment 2 doesn't matter as long as one's 1 and one's 2. Yeah?
I don't know.
Not for this one. The one inside the triangle is the altitude. So this is always the altitude.
And you're trying to find X.
And you're trying to find X, yep.
Wait, so X equals 12.
So, nope. So 2 over X equals X over 12.
See, the part where you do like it's x squared and then you times.
That's why I gave credit just for setting it up. But now we're going to keep going. No.
Oh, damn.
So this, no. You could also have done 12 over X equals X over 12. Over 2. It totally doesn't matter. Because you're going to multiply those 2 numbers together. It doesn't matter what order you do that in. All right, so if I cross multiply, which we now are masters at, right? I would get 2 times 12 equals x times x.
Oh my god.
Or 2 times 12. I don't even want to work through that because what's going to happen? I have to square root it anyways. So I square root and I square root.
24.
It's the square root of 24 though, right? So I'm going to leave it separate because I'm going to break it down.
4 and 3 is 4.
So I can do 4 and 3, 2 and 2. All those numbers would be the 2 that's there. So 2, 2, 2, 3. Lovely. 2 2s means a 2 goes to the outside. A 2 and a 3 stays underneath. We don't need to make this a competition of who could be grosser.
That's only big.
Now the x and y are in what location on that
On the
triangle?
outside the leg.
They're the legs, right? So let's do x first.
14.
First of all, this is hypotenuse
We're gonna do x too?
over leg equals leg over segment of the hypotenuse adjacent to the leg.
It's green.
What's the hypotenuse of this triangle? 14, and I got that by adding the 2 and the 12, right? It's that whole side.
Wait, why is it?
Hypotenuse, because that's the proportion, right? Hypotenuse over leg equals leg over the segment. Why is that side the hypotenuse? Is that what you mean?
We're using the same
Why is it top different?
Because this is the right angle in the big triangle, and opposite the right angle is that big long side. So I added them to get to the hypotenuse, which is 14. Now we're going to solve for x first. So x is one of the legs. That leg repeats, so it goes there again. Now I want the segment of the hypotenuse. David, say with us. Segment of the hypotenuse that's adjacent to the x. What's next to the x? 2.
That's a bad word.
No, I literally means crazy odds.
What the heck? Don't try the Hispanics.
So now I cross multiply 14 times 2, shush, equals x times x. X squared would equal 14 times 2. Again, you can multiply that out, but you're just going to end up breaking it down. So you might as well leave it separate.
Separate. You can only break that down to 7 and 2.
Yep.
Oh, and then 4 and no, 9. Who? Yeah, oh yeah, it's 2.
So this would be 7 times 2 times 2, right? Does anything repeat? 2 repeats. 2 root 7.
Yeah, what was it? Me too, that's why I was like, wait, what?
Oh, you thought I was leaving it there.
Yeah,
No,
we're like, huh?
Nope, not
That's
done.
when they told the hell that. I was like, you lost so.
All right, now do the y. So hypotenuse is what?
14.
Still 14, right? Stays the same. Now the y is the leg I want to solve for.
It's gonna be 12 now.
Good. Y repeats. The segment of the hypotenuse that's next to the y is 12. So I get 14 times 12 equals y squared. Y equals, guys, shh. 14 times 12. So 14 breaks down to what? 2 and 7, 12.
2 and 4 and 3.
2 and 6 are 4 and 3, and 2 and 3, right? So this is 2, 7, 2, 2, 3. 4 and 3 is fine, but then the 4 goes 2 and 2 again. It's still the same numbers at the end.
I have 72.
So one pair of 2s goes to the outside. There's no match for the 7. There's no match for the 2. And there's no match for the 3. Good. Yeah, so this would be 6, and 7 times 6 is 42.
But can't you break that down again?
Nope, because it'd be 2 and 21, 3 and 7, still same numbers.
6 doesn't matter. Oh wait. What the? Wait, the 6 doesn't matter.
Wait, what is x again?
X was 2 root 7. All right, you got like 2.5 minutes to do that last one.
I know